We're going well over 1,000 horsepower at this. It really helps the low lift numbers. The throats have been opened up, the bowls all blended really nice. All right, it's gonna get kind of loud, so let's see what it does. All right guys, so today we're in the race shop because the flow bench is here and we are working on the stage 2 12 valve head for my personal 98 12 valve daily driver. We're going well over 1,000 horsepower at this. Now these have never been on the flow bench, for at least for you, the YouTube audience. So today it's really exciting. We're gonna put this stage 2 power driven ported 12 valve head on the flow bench. Now a couple quick specs for the tech guys. A factory head or stage 1 that we start with, that's a stock valve size. The main difference on the stage 2, the port job's a little bit bigger because it's complemented with a larger valve. So the intake valve goes from a stock 1.77 inch to a 1.87 inch. So 100 thousandths bigger intake valve. The exhaust went from stock 1.65 inch to 1.75 inch, 100 thousandths bigger. So really it has 100 thousandths oversized valves, which allows us to go a little bigger on the port job within the limits of the factory casting, because we don't want to hit water and make this head, you know, not usable on the street. I mean, we could fill the head and go even bigger, but this is about as gnarly as it gets for a wet head on a factory casting. Before we put a head on the flow bench, we need to put lightweight springs in there. We call these like setup springs or test springs, because we actually use a dial indicator to open the valve at, you know, precise valve openings so that we can compare this head to like a stock or to our stage 1 so that we know exactly how far it's opening. Well, you can't push open a big heavy factory valve spring. In fact, well, this is a 24 valve spring. So these are even lighter than the 12 valve. You can see there's no way a dial indicator is going to push that open. So we got to put these lighter springs on. And everybody's going to ask, where did I get these? These came from my local Ace Hardware. I bought all the springs they had over the course of a month, and I finally got enough that I could build a setup springs. But they just go on here like this. Pretty simple. And then we're going to use our big 10-degree locks and chromoly retainers just because they're easier for me to manipulate with my big hands. Kind of. There, now that's there. Look, I can open it with my bare hand, see? So that's what we want, easy to open. Get one more spring here, number 6, then we're ready to flow. Ready to go. All right, let's get a little close-up of these ports real quick. All right, one difference on the stage 2 head is the valves are de-shrouded more. So in the CNC program, there's a little bit of an oval put around the valve, and essentially it just cuts a little bit of relief right here. It really helps the low lift numbers. So these stage 2 heads theoretically should flow more at low lift than the stage 1s because they got a little bigger valve and they've got a little more de-shrouding on the valves, or a little bit of relief in the head there. We don't do that on the stage 1 heads because we want to maintain as much compression as possible for people. And 2, the stage 1 heads aren't looking for all-out flow. So we don't want we don't want to expose the valves to unnecessary heat if somebody's going to run it for 1,000,000 miles or whatever. But on a stage 2, you're kind of getting more into the like high-end performance stuff where, if a tiny bit of reliability, or if the head's a little more prone to cracking because there's less material there, that's not really. The goal is to make horsepower with a stage 2 head. So let's see what this does. Well, actually, let's get a little closer look. I'm going to pull these valves out so you guys can see what the port looks like. Okay, let's pull out the intake valve and get a little closer at the bulwark. So in the valve, you'll see that the throat's been addressed because a bigger valve requires a bigger throat to have optimal flow. Usually you want about 90% on the throat. So the throats have been opened up. Then down here in the bowl, there's a big swirl boss here that's been totally hogged out by the CNC. But if you'll notice, if you get really tight here, there's dual swirl ramps. which is pretty cool. So there's 2 ramps for the air to swirl, and it seems to allow, at low lift, it still has the normal flow that goes slower when the port's lazy. It can kind of use both and use the whole valve, and then at high flow, it's out of the way for just gross flow. So this is something we played with on the Stage 2, and we found some flow gains with the dual swirl ramp in here. So that's one of the cool features of the Stage 2 ported head, is it's got the dual swirl ramps where the Stage 1 doesn't. That's just part of, you know, picking up flow. So on the intake valve, because the piston is centered right here, air tries on the intake to go more towards the center. So this program's been tweaked so that it allows more airflow to go towards the center of the cylinder. It just allows for better flow numbers, and you get better cylinder fill. The exhaust, let's move over to the exhaust now. The exhaust is a little different. Exhaust flow tends to follow the edge of the cylinder wall. So if the edge of the cylinder wall is out in this region here, there's more exhaust flow trying to come in right on the edge of the cylinder wall than in the middle, just the way it goes. But the problem is the air's got to bend. So there's been some work done on the short side radius. The bowl has been lowered down so that we can get, because you want the bowl to be up, you know, around 100% or 98%, you know. So the bowl on a factory Cummins is smaller than the actual valve area. So there's a lot of restriction, but there's water here, so you can only go so much. But anyway, a lot of work went into the bowl on this exhaust to get optimal flow. I mean, this is probably revision number 5 of back and forth between tweaking stuff to make these Stage 2s just a flow monster. Well, they're not like warhead flow monster, but for a street truck and with the factory casting, these things are pretty legit. Now this is the first final CNC'd one I've been able to test, so I don't know how well this is going to do versus what the hand porting and the port development work that I did on here, but those were pretty promising numbers, and usually the CNC follows the hand port stuff pretty well when they digitize the port. But let's take a look at where the exhaust actually comes out of the head. So you can see how this has all been hogged out where it matches the gasket. We can only go so far on this because we start getting into where the casting gets thin here. And you know, you don't want this to crack under the heat and stress. And at the same time, you don't want to go really bigger than the gasket or the manifold that's going on there. Now, if this was an all-out race truck, we would thin the gasket, we would thin the manifold on the Steed, we'd do everything we could to get maximum and not necessarily have reliability. But this is my street truck, so I'm not going to get these paper thin chasing 10 CFM. It's just not worth it. But you can see how the bowl's all blended really nice into here. And yeah, it's just, you can see daylight through the port. I mean, that's pretty good when you can see daylight through there. I mean, that means exhaust doesn't have to bend a lot to come out. It's really good. So I could talk and talk about this all day, but at the end of the day, if it doesn't flow, it doesn't matter. So step 1, design a good port. Step 2, see if said port flows well. And then step 3, put it on the truck and see if it delivers the horsepower goods we're looking for. So we've already got step 1 done. We've designed a good port with good percentages, good throat, good chamber volume, all that kind of stuff that we want to mess with in here, runner volume. Number 2, let's see how it does on the flow bench. All right, first step when we're flowing ahead, we got to put this slider plate on here. This lets you perfectly line up all 6 cylinders with the dowels and square to the machine. Because you're testing flow numbers, if the head's a little crooked on there, you can get changes of 5 or 10 CFM that you can't explain. So you want consistency when you're flowing stuff. I know guys are going to complain that I'm using a metal hammer and I could accidentally hit the deck. Trusty Mr. Stanley's been with me a lot of years, all right? The handle doesn't even stay on anymore. But you know what? It's been a loyal hammer. I've had this thing for, 20 years, It's built a lot of race cars. It really hasn't built any race cars. But it's broken a lot of things. All right, now we just got to get the slider plate on here. The only problem with Cummins heads is they're heavy, but luckily once they're ported, they're a little bit lighter weight. And 12 valves are lighter than 24 valves. 24 valves, they're a bear to get up onto the flow bench. Like, I kind of need an overhead crane, but you know, in the little race shop, I don't want a crane in my way all the time, so we just kind of manhandle this. All right. Well, let's start on the easy one. Let's start on cylinder number 3 here. See how it flows. So what this cool thing does, I guess we're starting cylinder number 4 because that's how the thing's set up. What we're doing is we're putting this dial indicator on here so it can precisely open the valve, but you want this rigid. This nice little fixture. And then always want to remember to plug the injector hole. If you don't, it seems like they pick up about 7 CFM. So if somebody's giving you some bogus flow numbers, I've seen some heads that were pretty high. We put them on the bench and they're nowhere near that. Seems like a lot of guys forget to plug the injector hole. So it's a good way to cheat 7 CFM, but we don't cheat around here. We're going to just show you the actual data, what it does here. So we are on cylinder number 4. So I've got to line up my notch here on 4. All right, we're going to start on the intake side because that's what's lined up. Okay, we zero the dial indicator. Lift this up, make sure it's not moving. Now we're going to open the valve 100 thousandths. 50, 100. You can see at the valve here, look, see? Let me back it off. 100 open, see? Now, a lot of guys don't even flow their heads at 100 because they feel like it's a meaningless number. The valve barely spends any time there. I like to float at 100. I feel like it shows us a little bit better, like the way the valve and the seat's designed and the deshrouding. I feel like if we spend a little time there, we can see gains. Now, it's not going to make big horsepower differences, but I do feel like it kind of shows a little bit of, not necessarily the quality of the valve job, that kind of shows it more at like 300 or 400 lift, but it shows the quality of the deshrouding and the back cuts and kind of your coefficient of discharge. If you have a really well-designed port that's not just big and lazy, they actually will still flow pretty good at 100, where when you hog it out really bad, sometimes you know you lose quite a bit at 100. Guys that are chasing big flow numbers for advertising, they don't care at 100. They don't even want to show you. They're almost embarrassed because they'll flow less than stock at 100. Well, this head, I've already flowed the hand-ported stuff. It definitely flows better than stock. But let's turn this machine on and, oh, I need my earmuffs. It gets kind of loud. All right, I realize a lot of you guys have never been around a flow bench or know how they work. Essentially what they are is it's a precise measuring device that flows air in or out of the head. So since we're doing intake, it's actually like a big vacuum cleaner. It's going to suck in the intake where it normally would go through the open valve, through this fixture assembly and out. And then it's got precise measuring devices in there. Most flow benches or most flow rating are done at 28 inches of vacuum. Essentially, you're looking for, that equates to a 1 psi pressure drop across the machine through the port. So that would be kind of like what it would flow at 1 pound of boost would be a good way to figure out what that is. But they're doing vacuum, not boost, but it's essentially the same. If you turn this up to 30 or 40 inches, which this machine can go that high, you can cheat and get higher numbers. But the kind of standard everybody uses is 28 inches. So anyway, it's on intake. When it's on exhaust, the machine flips around the fan direction or whatever it does inside. It moves some stuff you can hear, and it will blow out the exhaust valve so it'll actually exhale air out of here. It actually starts getting kind of warm. It'll warm up the head casting a little. So that's essentially how a flow bench works. It just simply sucks air in or blows it out. It precisely measures it, and because the way it's all calibrated, it knows what CFM of airflow in the settings it on equates to that amount of vacuum, and really the pressure drop. It's got some little pipette things that measure. It's measuring pressure drop across its sensors, and that's how it knows how much airflow. So it determines air speed by the pressure drop across the sensors, and by air speed with its calibration figures out the flow. So kind of scientific, but at the end of the day, it's just a fun toy to play with. So we're going to go into here in our range setting. So right now it's on 5, it'll read up to that, but since we're going to be less than 100 CFM, it won't read in range 5, so we're going to drop this down to range 3. So this reads accurately up to 95 CFM, but it also reads accurately down to like 42 CFM. Since the intake valve I know is going to be somewhere in that 50 to 60 CFM range, we want to put in that range so it's just more accurate. And then the final thing, you got to have a notepad so you can write down your information. So we'll get a clean sheet here. All right, it's going to get kind of loud, so let's see what it does. 100 lift, intake, kind of excited. See, 28 inches. Okay. So what that means is once I went to 200 lift, you saw, it flowed out of the flow range of that. So now I need to put it up on the higher setting that can read over 100 CFM. And generally it'll stay on that setting all the way on the stage 1 heads. This one, if this one gets over 200 CFM, we're gonna have to go up one more setting when we get up there in the high 190s. But so this setting can read accurately up to 196 CFM, from basically 100 to 196. And anyway, so far we're doing good. 62 CFM at 100. Stock heads usually are like 58, 59 CFM. So we're up 3. I mean, it's not really a lot, but I've seen some performance heads that are down in the 40s at 100 lift because they don't worry about that. But this one obviously is better than that. And 58. All right, so this head peaked out at 196 CFM. That's pretty decent. Stock heads down in the 135 to 140 range. You know, I've seen some stock ones as high as 145 on the intake. You got to remember too, this still has an intake shelf. So you can't pour it in there. All you can really do is what you can reach in the bowl. So getting 196 CFM, let's say roughly a roughly a 60 CFM gain just by working in the bowl. All you can do, not bad. Let's see what the exhaust does. Remember, the exhaust, we can work on both sides. And two, getting rid of drive pressure in the exhaust really seems to help with EGTs, reliability, turbo spool up. It seems like the better we can get the exhaust flowing, the better these things run on the dyno. So let's see what we can get out of this exhaust side. Okay, pretty easy for the exhaust. We just loosen this handle here, right here. This whole little assembly just slides over. Kind of line it up with the valve, lock it down. Okay, so we're zeroed, so let's go to 100 lift on the exhaust. Now we've got to move the machine so it's on the exhaust mode. So we're going to go in here to F3 in the test. Range setting. Move it to exhaust. You hear it moving all the fancy stuff inside there. It's kind of nice. I've been on like old flow benches where you had to actually move stuff from intake to exhaust. You had to switch the direction of the motors. You have to pull plugs and stuff in and out. It's quite there. Where these new benches, you just hit a couple buttons and it's kind of nice. More loud this time because it's exhaust. I'm going to probably put my headphones in. Hopefully we don't blow up the mic. So that was 60 CFM at 100 on the exhaust. So the exhaust is 2 CFM behind the intake at 100. But remember, the exhaust valve is 1,750 and the intake's 1,87. So it's over 100,000 smaller. So that's not too bad. It's flowing almost the same. Let's see what it does at 200 lift here. All right, so we already have to go to the higher range setting and we're at 400 lift, which is good. That means it's over 200 at 400. So it started at 60, it went 115 at 200, so it's 5 CFM higher. So it's 2 CFM lower at 100. It's 5 CFM higher at 200 than intake. At 300, it's 5 CFM higher, but at 400, this exhaust freaking takes off. I'm kind of excited to see what this does here. Look at it. 214, that's getting moving some air. I got all the way over here. Look. All right, enough screwing around. Okay, come look, final number. 222. Flow bench is pretty impressive when you really see the volume of air coming out of there. So this exhaust did not disappoint. Peaked out at 222. So it flows 4 and 22, so 26 CFM more than intake. That's a great port. I think the theoretical max you could get if this was like a totally re-engineered head that was like a billet, like you designed that size valve, a 1.750, you could theoretically get almost 250 CFM out of that, but not within the constraints of a casting. That's a really good, that's flown pretty good for a factory head here. I guarantee you put this on your truck, you're gonna notice a big difference. I'm expecting boost to be lower with this head, power to be up, which means your turbo's in better efficiency range. That's one thing we've noticed. We get a really good flowing head and the power numbers go up. We've always wondered why the Junker's making so much power. It has a stage 2 head, but I never flowed the one that was on it, and if it flows anything like this stage 2 head, that might explain the 1,500 horsepower we're making on that truck. So, guys, we test what we sell. These stage 2 heads legit flow over 200 CFM, 200 on the intake, 220 on the exhaust. I think you're going to be impressed how much power we can make with a 12mm pump that is street friendly, that starts well, and is a real ripper. Wait a minute, we're not done. 200 CFM on the intake, 220 on the exhaust. I know there's more in this head. So we're now the next day. I stayed up all night playing on the flow bench. A little tired, but I'm excited to show you what this thing does on the flow bench. So let's get this thing strapped back down, and I'm gonna show you the new power-driven stage 2, and it's a flow monster. We're starting at ground zero. I got a blank sheet here, but this is for you guys. I guess we need to open this 100 thousandths. All right, so numbers are in. The intake, 234 CFM. And remember, before the intake peaked out at like 200. So yeah, there was a lot more in the head with that same size valve. So these new stage 2s are gonna rock. Let's check out the exhaust now. Yeah, I was able to get some more on the exhaust too. All right, so final peak flow on the exhaust was 232 CFM. So I think the other stage 2 was like 220 on the exhaust. So we picked up another 12 CFM from me working over, some of the short side radius and some of the kind of more technical sides of the port. But anyway, it's always fun to find flow. This head is going to be a monster. To date, I have never flowed a factory style 12 valve head that flowed this much from any other manufacturer. Not cast and shade or whatever, but yeah, there's no standard, when you get in the warheads, we can flow more than this, but I've never seen a stock ported or even an aftermarket stock casting, performance casting or whatever that uses the stock valve train and stuff that flows this much. So this is an awesome head. Getting over 230 is a big deal. Getting over 230 on the exhaust is huge. Nothing's up there even close to that. So this is gonna rock, guys. You can buy these heads over at powerdrivendiesel.com, and yeah, I think you're gonna see a big gain on your truck. You throw one of these on there.